How's it going, Algebra 1? We're starting off this year a little bit different, but that's okay. So, these are your video notes, and we're going to be doing this pretty much every week for your asynchronous time. It's going to be me going over some explicit problems that'll kind of help you understand what we're doing throughout the week, and they're essentially your notes. So, you will probably want to write these down and look at the OneNote drive or whatever I've posted on Schoology, so that way you can take notes there too. So, without further ado, this week we are talking about the properties of real numbers. So let's get to it.
This week, we are going to be talking about the properties of real numbers. And by the end of this video, I'm hoping that you're able to identify and use the properties of real numbers. Our key concepts and vocabulary. Two algebraic expressions are actually considered, and let me just type this in here, equivalent expressions if they have the same value for all values of the variables. So I want to go through all of our properties that we're going to be talking about. Our first property, the commutative property. The order in which you add or multiply does not matter. That's super important to know for any numbers such a and b. So a plus b is the same thing as b plus a, and this works for multiplication. So a times b equals b times a. Our associative property. The way three or more numbers are grouped when adding or multiplying does not matter for any numbers a, b, and c. So a plus b plus c equals a plus b plus c. So this is when we are adding or multiplying, and it's a grouping property. Same thing for a times b times c, or a times the quantity b times c. Our additive identity. We get into identities now. Our additive identity is essentially when we add a number plus 0, it's the same thing as that number, essentially. So for any number a, the sum of a and 0 is in fact a. And the multiplicative identity is very similar, except when not adding 1, and this time it's just multiplying by 1. So for any number a, the product of a and 1 is a. We also want to think about our additive inverses here. A number and its opposite are additive inverses to each other, essentially meaning a number and its opposite, when they add up together, create 0. Good example here. Our multiplicative inverse or reciprocals. Remember that nice word, especially when we're thinking about how do we divide by a fraction? We multiply by the reciprocal. So for every number a over b, where a and b does not equal 0, there is exactly one number, b over a, such that the product is 1. So essentially it's saying, and this is another really good example right here, if you have a fraction and you multiply by its reciprocal, that's going to be equal to 1. Let's erase that. The multiplicative property is 0. Anything times 0 is in fact 0. Duh. Newsflash. Here we go. A times 0 is 0, which means A is 0, and 2 times 0 is 0. And those are all the properties that we're going to be using. So let's go through and try to identify some properties. I'm not going to identify everything because I want you to be able to do that as well, but I'm just going to go through a couple. Let's erase that. So, example 1, what property is being illustrated? In this case, for A, we have z times 47 equals 47 times z. This is a good example of the commutative property. And I'm just going to do commutative prop. 9 times 1 over 9. That is an example of the multiplicative identity. And let's expand that out a little bit. For C, it looks like there's some grouping going on. So in this case, I'm automatically thinking the associative property. I'll just make it prop again, keep it consistent. And then 3 times x, y, z plus 0 does in fact equal 3 times x plus y, or times x times y times z. This is just the additive identity. On to example 2. Name the property, then find the value of the unknown. N times 12 equals 0. So I need to think about what times 12 is going to give me 0. In this case, it has to be 0. So this is an example of, wow, that is up high. Let's put it there. We'll move it down. The multiplicative prop of 0. And then, of course, n equals 0. For B, I see some grouping that's going on here. So I look to see what's different. Well, I can see that the 4 replaces the z, so obviously z would be 4 in this situation. So I'm going to type in associative property, associative prop, and z equals 4. 0 plus n equals 8. Well, anything plus 0, I know that that's going to be an identity. In this case, it's the additive identity. So 0 plus what gives me 8? Obviously, n has to be equal to 8. So this is our additive identity. And then n has to be equal to 8. And then 6 times h equals 6. This is obviously the multiplicative identity because it's anything times 1 is itself. So we're going to type in multiplicative identity. And we know that h has to be equal to 1. Let's move on to the next slide. Name the property used in each of these steps. So I need to go essentially, or I need to look, how can I go from this original to step 1, and then to the next step, and the next step, and the next step, and get all the way down to the end. So this is where you're really going to want to have your properties right by you. So in this case, I'm looking to see, I see that they changed right here. This originally was 3 plus 0, and now it's just 3. Which in this case, this tells me that this is just the additive identity. Let me move that up. For the second step, I see that they got rid of this 5 times 1/5 and just made it 1. This is going to be the multiplicative inverse. Multiplicative. Oops. Why are you not working? That's not nice. Multiplicative inverse. And we can move that up. Next, I see that they took care of this 3 times 1 and just made it 3, which in this case is going to be the multiplicative identity. That's not multiplicative, is it? There it is. Now it's multiplicative. And then finally, I see that they were able to get rid of this 3 minus 3 here. That is an example of additive inverse. So that's how I use all of my properties to get down to that final answer being 1. So let's go to the very last slide, providing a counterexample to our properties, and just to make sure that things are working. So they are trying to say here, is the statement true or false? If false, give a counterexample. For part A, they are trying to do, let's see, what property is it? They are trying to do the commutative property, or really the associative property. And they're trying to say A plus B, two numbers, is added together, is the same thing as them being multiplied together. So what I like to do in this situation is just test out some numbers, and I like to make them small. So let's go with A is 1 and B equals 2. So 1 plus 2 gives me 3. Does that equal 1 times 2? In this case, it does not. So that is our counterexample right there. B, for all real numbers, any number times 1 equals that number. Well, I know for a fact that is true because that is our multiplicative identity. And that would be why it's true.